Welcome to our channel. Today, we're diving into a fascinating topic, the simulation hypothesis. Could our reality be an incredibly advanced computer simulation? It sounds like science fiction, but some compelling evidence suggests it might not be as far-fetched as we think. From quantum mechanics to the universe's constants, we'll explore 5 mind-blowing clues that hint at the possibility of our existence being a simulated reality. Let's start with the strange world of quantum mechanics, where observation seems to influence reality itself. Consider the famous double-slit experiment. When particles are fired at a barrier with 2 slits, they act like waves, creating an interference pattern. But when we observe which slit each particle goes through, they act like particles again. This observer effect is one of the most perplexing aspects of quantum mechanics. It's as if the universe knows when we're watching and changes its behavior accordingly. Could this be a glitch in the simulation, a sign that our reality is being rendered on demand? Think of it like a video game where details are only loaded when the player is looking at them. This optimization technique could be mirrored in our universe, with observation triggering the rendering of reality. In a simulated world, computational resources would be finite. It wouldn't be efficient to render every single detail of the universe all the time. Instead, the simulation might only render what's being observed, conserving processing power. The observer effect could be a byproduct of this optimization strategy. The probabilistic nature of quantum mechanics, where particles exist in a superposition of states until measured, could be the simulation calculating probabilities in real time. Imagine the simulation running countless calculations behind the scenes, determining the outcome of events only when an observation is made. This could explain the seemingly random nature of quantum events. The uncertainty principle, which states that we can't know both the position and momentum of a particle with perfect accuracy, could also be a limitation imposed by the simulation. Perhaps the simulation's resolution isn't infinite, and there's a fundamental limit to the precision with which we can measure things. Think of it like pixels on a screen. You can't zoom in infinitely. Eventually, you hit the pixel limit. Similarly, the uncertainty principle could be the pixel limit of our simulated reality. Our universe isn't just a random collection of objects. It's governed by a precise set of mathematical laws. From Einstein's relativity to fundamental constants like Planck's constant, the universe operates with remarkable mathematical precision. This inherent mathematical structure could indicate that our reality is a computational system. Every computer program, video game, and simulation relies on underlying mathematical code. The characters, objects, and interactions are all governed by mathematical algorithms. Similarly, the universe's adherence to mathematical laws could be a sign that it's running on a similar type of code. Consider Einstein's famous equation, E equals mc squared. This simple yet profound equation describes the relationship between energy and mass, and it's a cornerstone of modern physics. The fact that such a concise mathematical formula can capture such a fundamental aspect of reality is remarkable. It suggests that the universe operates according to a set of pre-programmed rules, much like a computer program. Then there are the fundamental constants, like the speed of light, the gravitational constant, and Planck's constant. These constants are the building blocks of our universe, and their values are incredibly precise. Even slight deviations in these values would make life as we know it impossible. This precision is what physicists call the fine-tuning problem. Why are these constants so perfectly tuned for life to exist? One possible explanation is that our universe is a simulation, and these constants are parameters set by the programmers. Imagine creating a simulated universe. You would need to set the values of these constants to create a stable and life-supporting environment. The fine-tuning problem, then, could be evidence of this deliberate design. Furthermore, the very language of physics is mathematics. If our universe is indeed a simulation, then mathematics is the programming language of that simulation. Let's delve deeper into the fine-tuning problem, a cosmic puzzle that has baffled scientists for decades. The fundamental constants of our universe, like the gravitational constant and the cosmological constant, are incredibly precise. Even the slightest tweak to these values would render our universe uninhabitable. For example, if the gravitational constant were slightly stronger, stars would burn out too quickly for life to evolve. If it were slightly weaker, stars wouldn't form at all. The same goes for the cosmological constant, which governs the expansion of the universe. A slightly different value would either lead to a rapid expansion that rips everything apart, or a collapse back into a singularity. This delicate balance raises a profound question: why are these constants so perfectly tuned for life? It's as if the universe was designed specifically for us. One possible explanation, and one that aligns with the simulation hypothesis, is that these constants were deliberately set by the creators of our simulation. Imagine creating a simulated universe. You would want to create a stable and interesting environment, one where complex structures like stars, galaxies, and even life could emerge. You would carefully adjust the parameters of your simulation, fine-tuning the constants to achieve the desired outcome. The fine-tuning problem, then, could be evidence of this deliberate design. Another intriguing aspect of the fine-tuning problem is the anthropic principle. This principle states that the universe must be compatible with the existence of observers. Otherwise, we wouldn't be here to observe it. If our universe is just one of many simulated universes, each with different parameters, then it's not surprising that we find ourselves in a universe that's fine-tuned for life. Let's turn our attention to another intriguing aspect of our universe: the speed of light. This fundamental constant, approximately 299,792,458 meters per second, is the ultimate speed limit in our universe. Nothing can travel faster than light, not even information. This seemingly arbitrary limit could be another clue that we're living in a simulation. In a computer simulation, there's always a processing limit. The speed at which information can be processed and transmitted is finite. This limit is determined by the hardware and software of the simulation. Similarly, the speed of light could be the processing limit of our simulated universe. Nuclear physicist Silas Bean proposed an interesting idea that space-time itself might be a discrete lattice, like a grid of pixels on a computer screen. If this is the case, then the speed of light could be the speed at which information can propagate through this lattice. It's the maximum rate at which the simulation can update itself. Imagine a character in a video game trying to move faster than the game's processing speed allows. The game would glitch, and the character's movement would become jerky and unpredictable. Similarly, if something tried to travel faster than light in our universe, it would violate the fundamental laws of physics, potentially causing the simulation to break down. The speed of light, then, could be a safeguard built into the simulation to prevent such breakdowns. Furthermore, the fact that the speed of light is constant for all observers, regardless of their relative motion, is a cornerstone of Einstein's theory of relativity. This counterintuitive phenomenon could be another artifact of the simulation. Our final piece of evidence brings us to the cutting edge of technology, artificial intelligence, and virtual reality. The rapid advancements in these fields, coupled with Moore's law, make the simulation hypothesis increasingly plausible. Think about the video games we play today. They're incredibly realistic, with vast open worlds, complex characters, and immersive storylines. Now imagine what video games will be like in 100 years, in 1,000 years. If computing power continues to increase at an exponential rate, it's not inconceivable that we'll eventually be able to create simulations that are indistinguishable from reality. Philosopher Nick Bostrom's simulation argument adds another layer to this discussion. Bostrom argues that one of the following three propositions must be true. 1. Civilizations rarely reach a level of technological maturity capable of creating realistic simulations. 2. Civilizations that reach this level rarely choose to create such simulations. Or 3. We are almost certainly living in a simulation. If we assume that civilizations will eventually reach the technological capability to create realistic simulations, and that at least some civilizations will choose to do so, then the probability that we're living in a simulation becomes significantly higher. The rapid advancements in AI also lend credence to the simulation hypothesis. As AI becomes more sophisticated, it's not hard to imagine a future where AI can create and run its own simulations. Perhaps we're already living in a simulation created by a superintelligent AI. Thanks for watching. If you found this video intriguing, don't forget to like, share, and subscribe for more deep dives into the mysteries of our universe. The simulation hypothesis is a mind-bending concept that challenges our very perception of reality. While we may never know for sure whether we're living in a simulation, the evidence we've explored today certainly gives us pause. Let us know in the comments what you think about the simulation hypothesis. Until next time, stay curious.